Topic 3 is about PN junction diode. In electronic devices and circuits, uh, when we are dealing with active devices, there are various types of active devices like PN junction diode, bipolar junction transistors, and field effect transistors. In this topic, we'll see in detail about PN junction diode. Uh, A diode is an electronic component, is an active device that allows current to flow only in one direction. This is how physically a diode looks like. It's a two-terminal device, and its two terminals are known as anode and cathode. And the above one is the symbol of a diode, which is represented by making use of a arrowhead and a straight line. The terminal representing the arrowhead is an anode, and the terminal nearer to the straight line is a cathode. So, PN junction diode is a two-terminal device wherein the terminals are anode and cathode. This is how a PN junction diode is being formed. It is formed by doping one side of a piece of a silicon, a semiconductor, with a p-type dopant impurity like boron, and the other side with a n-type impurity dopant like phosphorus. Yeah. Either we can make use of germanium or silicon. Any one of the semiconductors can be considered. And the PN junction diode is a two-terminal device, and this is how its basic structure looks like. The left side one is a p-type material. Now the right side one is a n-type material. When these two are mm, used, p-type and n-type material are used, and they are diffused. The p-type material will have a majority of holes in its side, and the n-type material will have a majority of electrons in this side. So when these two are combined, p-type and n-type materials, the majority carriers which are there in the p-type material will try to cross this junction and try to get into the n-type material where the majority carriers are electrons, and the majority carriers of n-type material which are electrons, they try to cross this junction and enter into the p-type material where the majority carriers are holes. In this way, the majority carriers of p-type and n-type will get attracted towards each other nearer to the junction, and they get nullified when a p-type majority carrier hole gets combined with electron. The n-type material majority carrier they get recombined. So as a result, nearer to this junction will have only the negative ions towards p-type and the positive ions towards the right side of this depletion region. Yeah. Coming to the PN junction diode forward bias, to bias the PN junction diode, for forward bias, the p-type material will be connected to a positive terminal, and a n-type material will be connected to a the n-type material. When a p-type material is connected to the positive terminal, the majority carriers of the p-type material, which are holes, will get repelled by the positive terminal, and they get repelled by the positive terminal and move towards the junction and to cross and get into the n-type material. Similarly, the electrons, which are the majority carriers in the n-type material, will get repelled by this negative terminal, and they get towards the depletion, this region, this junction. They try to cross the junction and get into the p-type material. In this way, the flow of the movement of the majority carriers takes place, and after applying certain voltage, the junction breaks down. No, no. After applying certain voltage, the free movement of the charge carriers from the p-type to the n-type will takes place, and the depletion region will become very narrower, and the easy movement of the carriers will start, which leads to the flow of the current in one direction.